students, we are back, and for today we will be discussing quarter 1, week number 7. And our topic will be all about proving the remainder theorem, factor theorem, and rational root theorem. For the learning competency, the learner proves the remainder theorem, factor theorem, and rational root theorem. So let us start with lesson number 1. Of course, we will start with the remainder theorem. For the remainder theorem, you will start with activity number 1, which is to identify the remainder in the procedure shown in each item. So there are 2 procedures, and you're going to answer the questions below. So in this lesson, you will learn another method that you can use to determine the remainder when dividing polynomials. Let us now proceed with the definition of the remainder theorem. The remainder theorem tells us that if you divide a polynomial p of x by x minus c, then the remainder r is a constant equal to p of c. So we have it here, r is equal to p of c. Hence, there are 2 ways to find the remainder p of c when a polynomial p of x is divided by a binomial x minus c. First is using synthetic division, and second by calculating p of c or using the remainder theorem. Let us first prove the remainder theorem before we illustrate through examples. So, as you can see on the next page of your CAPSLET, we can see here the proof of the remainder theorem. So please follow. Suppose polynomial p of x is divided by a divisor of the form x minus c, where c is a real number. Dividing a polynomial by x minus c gives a remainder of either 0 or a polynomial that has a degree less than the degrees of x minus c. Since x minus c is with degree 1, this means that the degree of our remainder must be 0. Therefore, our remainder is a constant. Okay, let's proceed with the proof. With x minus c as the divisor, the division algorithm tells us that p of x is equal to x minus c times q of x, or what we know as the quotient, plus the remainder. So if we evaluate it using p of x at c, it gives us p of c is equal to c minus c. So if you notice here, we just changed the value of x into c. So this becomes c. And then times q of x plus r. So by definition of the multiplication property of 0, this becomes p of c is equal to, so we will subtract this now, c minus c is equal to 0. Okay? And then times q of x, and then plus r. Okay, we proceed, we simplify further, so we have p of c is equal to, so take note that we will multiply the 2. So 0 times q of x, so any number when you multiply to 0 is equal to 0. So we have 0 plus r. So that is the result why we have this equation here. So by definition of multiplication property of 0, so we have p of c is equal to 0 plus r. And we know that any number, when added to 0, it is equal to itself. So we have here p of c is equal to 0 plus r, which is equal to r. So that becomes our final answer. Thus, this is our proof for the remainder theorem. Okay, now let us proceed with the examples. Find the remainder when negative 8x squared minus 4x plus 1 is divided by x plus 2. So of course, negative 8x squared minus 4x plus 1 is our dividend, and x plus 2 is our divisor. Solutions. In this example, our divisor is x plus 2. When expressed as x minus c, so it becomes x minus negative 2. Hence, the value of c now is equal to negative 2. So let us show both methods in finding the remainder. So as mentioned earlier, so we can use 2. The first one will be using the synthetic division, and the second one will be using the remainder theorem. So, knowing that we have already discussed synthetic division, so let us have our solution now. So, remember, if you use the synthetic division, you have to always make sure that both the dividend and the divisor are written in standard form. So, as you've noticed, it is already written in standard form. And what you're going to use here are all the coefficients of the dividend. And as you can see here, we have -8, okay, -4, and then we have +1. And on the left side, we have the value of C, which is -2. So let us start with our solution. Okay, first, we will bring down the first entry, -8, followed by multiplying -2 to -8. Our result is +16, okay, and then we will add it vertically. So, -4 plus 16 is +12. Okay, after that, we will multiply -2 to +12, and the result is -24. And then we will add it again, so we have 1 plus -24, we get -23. So, since that's our last entry, therefore, using the synthetic division above, it shows here that the remainder is equal to -23, which is the last entry. Now, let us see if by using the remainder theorem, we will still be having the same result. So, this is how we're going to do it. So, by remainder theorem, let us evaluate P of X at C by substituting C equal to -2 for X. So, ibig sabihin lang, papalitan natin lahat ng value ng X to the value of C, which is equal to -2. So, our original equation, we have P of X is equal to -8x squared minus 4x plus 1. So, the value of X here now becomes -2, which is the value of C, because this becomes now P of C. So, P of -2. So, once may -2 na dyan, papalitan natin or substitute all the values of X to -2. So, we have -8 times -2 squared minus 4 times -2 plus 1. Okay, after that, we can now evaluate. So, let's do it one by one. So, P of -2 is equal to, so we'll start with what is inside the parenthesis. So, we have -8, just copy that, and then -2 squared is equal to +4. -2 times -2 is +4. Then, we can now multiply these two. -4 times -2 is equal to +8, and then plus 1. Okay, simplify further. -8 plus, or -8 times 4, it gives us -32. And then, we can add this already. So, 8 plus 1 is equal to +9. And then, we have now P of -2 is equal to, so we get -32 plus 9 is equal to -23. So, if you notice, using this another method, which is the remainder theorem, we came up with the same remainder of -23. Okay, so pareho silang dalawa. Now, it depends to you whether you want to use synthetic division or remainder theorem. So, which do you think is more easier for you in finding the remainder, so you can use that as your solution? Okay, so for this, you will now be asked to answer the SAQ questions 1 and 2. Okay, so for your practice, you can do this activity. You're going to evaluate each polynomial given the values of X, which is on the table. So for letter A, you have here the given polynomial. And then what you're going to do, since there are 5 values of X, so you're going to solve it one by one. So, unahin nyo muna si -3. You substitute -3 to all the values of X, and then you simplify, and then you write your answer here. And then same as if -2, and so on. So, you just continue until you complete the table. And then a message will appear, no, from the given letters below. Same as with letter B. And then you have to answer the questions. Okay? Also, you have to remember some of the key points or important concepts regarding remainder theorem. And you are going to answer the assessments below. Okay, so we have 3 assessments. So that is for the remainder theorem. Now, moving on with lesson number 2, which is all about the factor theorem. So you have there the activity. So please do the activity so that you will be able to answer the given guide questions. So actually, this activity will allow you to recall what a factor is all about. So for example, 3 and 2 are factors of 6 because when you multiply 3 and 2, it will be equal to 6. So 3 and 2 are factors of 6. So in this lesson, we will be taking the concept of factors to a higher level, which is in polynomials. Okay, so let's have first the factor theorem. Okay, so the polynomial p of x has x minus c as a factor if and only if p of c is equal to 0. So ano bang ibig sabihin nito? Actually, there are 2 explanations. If x minus c is a factor of p of x, then p of c is equal to 0. This tells us that if the divisor x minus c is a factor of the polynomial p of x, then the remainder p of c is equal to 0. So, dapat 0 yung remainder niya para masabi natin na factor yung divisor of the given polynomial. So, that's for letter A. We also have letter B. If p of c is equal to 0 or if the remainder is equal to 0, then x minus c is a factor of p of x. Okay? So, if the remainder is 0 when polynomial p of x is divided by x minus c, then it follows that the divisor x minus c is a factor of p of x. Okay? So, let us have here the proof of the factor theorem. So, there are 2 parts of the proof of this theorem. So, letter A, let's start with letter A. If x minus c is a factor of p of x, then p of c is equal to 0. So, let us prove that. So, we have it here. Suppose x minus c is a factor of p of x. Then, p of x, okay, take note of this, is equal to x minus r times q of x. Okay? Since the equation is an identity and is true for any values of x, then it must be true for x equals c. Then, we can have this equation here now. P of c, okay? So, since x is equal to c, so we will substitute here our p of x. This becomes p of c is equal to c minus c. So, from x minus r, this becomes c minus c times q of c. So, we know that when we subtract c to c, that will give us 0. And take note, by the 0 property of multiplication, 0 multiplied to any number, the result is 0. Thus, we can say here that p of c is equal to 0. So, that's for letter A. Next, for letter B, okay, suppose that p of c is equal to 0. By the remainder theorem, when p of x is divided by x minus c, the remainder r is equal to p of c is equal to 0. Okay? Then, if we are going to have this equation here, we have p of x is equal to x minus c times q of x plus 0. That is using the remainder theorem. Okay? And then, p of x is equal to x minus c times, okay, if we add this now, any number when you add it to 0 is just equal to itself. So that's why it became here x or q of x. So that is identity property of addition or for addition. Therefore, x minus c is a factor of p of x. This is by the definition of a factor. Okay, so we have this conclusion here. Okay, so to further understand what is factor theorem, let us have the examples. So first, let's have number 1. Show that x minus 1 is a factor of 4x cubed minus 4x squared plus 4x minus 4. Our goal here is that using the factor theorem, we must be able to show that p of c is equal to 0, because by that, if the remainder is 0, okay, therefore we can conclude that it is a factor. If not, then it is not. Okay, so let's have the solution. Using the factor theorem we have now, so we will have this one here. So, of course, we have here x minus c. So, if we substitute the value of c here in the given, so our c is equal to 1. Okay? So, we have now 4 times, using this equation here, or the expression here. So, we have 4 times 1 cubed minus 4 times 1 squared plus 4 times 1 minus 4. So, we'll answer it, or we will simplify it. So, we have p of 1 is equal to, so we'll start all the values inside the parentheses. So, 1 cubed or 1 raised to 3 is equal to 1 minus 4 times 1 squared is still equal to 1 plus, we can now evaluate this one. 4 times 1 is equal to 4 minus 4. Okay, so let's proceed now. P of 1 is equal to 4 times 1 is 4. Okay, negative 4 times 1 is negative 4. Okay, positive 4 minus 4 is 0. So, no need to write that. So, we have it here now. P of 1 is equal to 4 minus 4 is equal to 0. Since, okay, P of 1 is equal to 0, then we can say now that x minus 1 is a factor of 4x cubed minus 4x squared plus 4x minus 4. So, ganun lang kadali. Pag 0 yung result or 0 yung remainder, then we can conclude that the given divisor is a factor of the given polynomial. Okay? So, let's have another example. Example number 2. Okay, example number 2 is x plus 1 a factor of 2x squared plus 3x minus 2. So, let's figure out using the factor theorem. So, of course, in this case here, we have x plus 1. So, we will have it in the form of x minus c. Okay, so for it to become x minus c, so we have here now x minus negative 1. Kasi negative times negative is equal to positive. So, definitely our c is equal to negative 1. So, that is what we're going to write here. So, we will now substitute it in the given polynomial. So, we have 2 times negative 1 squared, okay, plus 3 times negative 1 minus 2. Okay, and then p of negative 1, okay, is equal to 2 times, so negative 1 squared is equal to positive 1. Negative 1 times negative 1 is positive 1. Then, positive 3 times negative 1 is negative 3 minus 2. Okay, simplify further. So, p of negative 1 is equal to 2 times 1 is 2. Negative 3 minus 2 is negative 5. And lastly, we have p of negative 1 is equal to 2 minus 5 is equal to negative 3. So, if you notice in our final result, since p of negative 1 is not equal to 0 because it's equal to negative 3, so hindi siya equal to 0, then we can conclude that x plus 1 is not a factor of 2x cubed plus 3x minus 2. So, ganun lang kadali ma-determine whether factor siya o hindi. So, dapat 0 yung remainder or 0 yung result when you use factor theorem. Okay? So, that's it for the factor theorem. So, you're going to answer SAQ question 1 and 2. And then for your activity, so you're going to fill the empty boxes below. So you follow the instructions given on the separate sheet, of course. And then the key points. So you're going to remember this. And then, of course, answer the assessment. So 3 assessments for factor theorem. Okay? And finally, we will now discuss lesson number 3, which is all about the rational root or zeros theorem. Okay? So, you're going to answer the activity given below, and also you have to answer the questions. Okay? So, you have to take note of the definition of zeros or roots. Zeros or roots of a polynomial are values for which, when substituted to the polynomial, gives 0. In symbol, if a is a root of x, then p of a is equal to 0. So we have here the rational root theorem. Okay, if the polynomial x is given has any rational zeros, then they must be of the form positive and negative p over q, which is equal to the numerators are all the factors of a sub 0 and the denominators are all factors of a sub n. So we recall this rational root theorem because all of the possible solutions are rational numbers. So below here you can see the proof of rational root theorem, so you can go over with it one by one. So not focus on this here, we will proceed right away with the examples. So, number 1, list the possible rational root of the polynomial p of x is equal to x cubed plus 5x squared minus 2x minus 24. So, this is what you're going to do step by step. So, please follow. Step 1, list the integers p that are factors of the constant term. So, the constant term of x cubed plus 5x squared minus 2x minus 24 is negative 24. So, tingnan nyo kung ano yung constant term. So, in this case, it's negative 24. Now, with that, you're going to list all the factors of negative 24, which is listed now here. So, let p be all the factors of the constant. So, what is written inside this bracket here are all factors of negative 24. So, ano bang ibig sabihin ng factors? Meaning to say, you're going to look for numbers wherein when you multiply these two numbers, it will give you negative 24. So, bakit nagkaroon ng 1, 2, 3, 4, 6, 8, 12, 24? So, pwedeng si positive 1 times negative 24. Pwede ding negative 1 times positive 24. Kaya nandyan yan sila. Okay, pwede din si positive 2 times negative 12 or negative 2 times positive 12. Kaya nandyan yan sila. Okay, you can also have positive 3 times negative 8 or negative 3 times positive 8. And you can also have positive 4 times negative 6 or negative 4 times positive 6. So all of these are all factors of negative 24. Okay, so once done, let's proceed with step number 2. List the integers q that are factors of the leading coefficient. Okay, kung si p, kanina, si p are all factors of the constant, our q will be the factors of the leading coefficient. So in this case, the leading coefficient of the given polynomial x cubed plus 5x squared minus 2x minus 24 is equal to 1. Saan nanggaling si 1? Okay, since the leading term is x cubed And we know that the coefficient of x cubed is equal to 1. Therefore, 1 is the leading coefficient. Now, listing the factors of 1 gives us q is equal to, very easy, positive or negative 1. Bakit may positive and negative? Because when you multiply positive 1 times positive 1, it will give you positive 1. And negative 1 times negative 1 will still give you positive 1. That's why you have their positive and negative 1, because both of them are factors of positive 1. Okay, let's proceed with step 3. Form all the potential values of P over Q equals to, all the factors of the constant will be the numerator, and the factors of the leading coefficient will be the denominator. Writing the possible zeros of the form P over Q gives us P over Q equals to, so magiging ganito. So if you notice, all the numerator are all factors of the constant, and then the denominator are all factors of the leading coefficient. Okay. So simplify the fractions and eliminating the duplicates gives us or give us the potential values of P over Q. So if we simplify 1 divided by 1, we get positive and negative 1. Positive negative 2 divided by 1 is still positive negative 2. So since all the denominator is equal to 1, of course, we know that we have this result. So 3, 4, positive negative 6, 8, 12, and 24. So, meaning to say this all values here. So, how many are the possible root? So, since we are counting the positive and the negative values, so we have 2, 4, 6, 8, 10, 12, 14, 16. There are 16 possible roots of the given polynomial. Okay? So, how are we going to determine kung alin lang dyan yung roots? So, we will solve it by using the P of A and make sure that it is equal to 0. So, pag 0 siya, then, therefore, we can say that it is a root. So, kapag hindi equal to 0, so we need to say hindi siya root. So, you are going to test all the possible roots. Okay. Now, let's have number 2. Para mas maintindihan natin, let's discuss number 2. So, list the possible rational root of the polynomial P of x is equal to 4x squared plus 7x minus 2. So, this one. So, step 1, of course, identify the constant. Okay? And then we will get the factors of all the constants. So, list the integer P that are factors of the constant term. So, we have the constant term, obviously, it's negative 2. So, we have it here, negative 2. So, listing the factors of negative 2, this gives us P is equal to positive negative 1 and positive negative 2. Bakit dalawa lang? Kasi 2. Pwedeng positive 1 times negative 2 is negative 2. Pwede ding negative 1 times positive 2 is negative 2. So, there are 4 factors. Okay, so that's for P. So, let's have now step number 2. List the integers Q that are factors of the leading coefficient. So, looking at the given polynomial, our leading coefficient here from the leading term, so we have 4. So, our leading coefficient is 4. So, listing the factors of 4, this gives us Q is equal to, so there are 6 possible factors. Or 6 factors. So, positive negative 1, positive negative 2, and positive negative 4. Bakit? So, we can have positive 1 times positive 4. It will give us positive 4. Negative 1 times negative 4 will still give us positive 4. Positive 2 times positive 2 is positive 4. And negative 2 times negative 2 is positive 4. So, 6 sila. Now, once done, let's proceed with step number 3. Form all the potential values of P over Q in the given. So, writing the possible zeros of the form P over Q gives us, so we have it here. So, let's start with the numerator, which is equal to positive negative 1. So you have 1 divided by 1. So 1 divided by 1. So we have it here. And then 1 divided by 2. So we get here. And then 1 divided by positive negative 4. So we have it here. Next, we'll proceed if the numerator is positive negative 2 divided by positive negative 1. So we have here. Followed by positive negative 2 divided by positive negative 2. So we have it here. And then positive negative 2 divided by positive negative 4. And we have this here. So we will simplify first. Simplify the fractions and eliminate the duplicates. So this gives us, of course, 1 divided by 1. We have this here. And then we have 1 over 2, positive 1 over 2. So we'll still have positive 1 over 2. And then positive negative 1 over 4, still positive negative 1 over 4. And then positive negative 2 over 1 is equal to positive negative 2 kasi 2 divided by 1 is 2. Next, positive negative 2 over 2, 2 divided by 2 is still equal to 1. So, andito na siya. Okay, so we will not write it again. So, andyan na siya. And then, positive negative 2 over 4, if we simplify that, it will give us positive negative 1 over 2. So, andito na rin siya. So, hindi na natin isusulat pa. So, all in all, if we are going to count it, there are 2, 4, 6, 8. So, 8 possible roots. Okay? So, it's up to us now to identify which among the following are the real roots by solving it. So, we have to make sure that P of A is equal to 0. So, kung alin dyan yung ginamit nating value of A, which will lead to 0, then that is the root. Okay? So, we are done. So, you're going to answer SAQ number 1 and 2. Also, you have to practice by answering the given activity. Here are the key points. And then, answer the assessments. Okay? So, that's it for today. If you have any questions, please do not hesitate to contact your subject teacher. I hope you have learned something today. So, till next time, goodbye!